Hi students, welcome to physics class. Today we are going to discuss a new concept, that is radius of gyration. Once again, today we are going to discuss about radius of gyration. Take an axis. Consider here the rotation is anti-clockwise direction. Take mass of a particle m1. Its position vector is r1, and take mass of a particle m2. Its position vector is r2. Take mass of a particle is m3. Its position vector is r3, and so on. Take mass of a particle is, and so on, mn. Its position vector is rn. Now take it is a system. Take it is a system. The whole mass of the system is, consider capital M. It is, this axis is considered as axis of rotation. Consider it is a point A. Consider it is point B. Here it is A, this is point B. This is, we can call it, this straight line we can call as axis of rotation. The whole mass of the body is considered as capital M. The whole body we can call as a system. Consider a point here. This is considered as K. This K is at a distance from the axis of rotation. This is a K. This is at the axis of rotation. K. This K we can call as radius of gyration. Now go for definition. What is radius of gyration? The radius of gyration of a body, it is the, which can be defined as, it is the distance from the axis of rotation at which the whole mass of the body was concentrated, and without changing of its moment of inertia, is called radius of gyration. Radius of gyration, which can be defined as, it is the distance from the axis of rotation at which the whole mass of the body was concentrated without change of its momentum of inertia, which is denoted by capital K, is called radius of gyration. Now go for definition. If your body If a body rotate about an axis, the radial distance from the axis where the center of mass is concentrated without changing in moment of inertia. This radial distance is called radius of gyration. And denoted by K. And also it is the distance from the axis of rotation at which the whole mass of the body at which mass of the body were concentrated without changing of its moment of inertia. It is denoted by K. My dear students, here I teach two definitions. Of course, both are similar. However, it will be support you to write properly in exam. Suppose a rigid body rigid body consists of small n particles of mass small m, each situated at a distance R1, R2, and so on Rn from the axis of rotation AB. What is the name of axis of rotation? AB. Now, the moment of inertia of the body about the axis is given by that is I is equal m1 r1 square plus m2 r2 square plus and so on plus mn rn square. Here m1 is equal m2 is equal m3 is equal and so on is equal mn is equal small m. Therefore, I is equal m r1 square plus m r2 square plus and so on plus m rn square. which is common? M is common. So take M as common. Therefore, I is equal to M as common R1 square plus R2 square plus and so on plus Rn square. Now multiply by n number of particles. At the same time, divided by n number of the particles. R1 square plus R2 square plus and so on plus Rn square whole by small n. What we did here? Listen carefully. I multiply by n, at the same time divide by n. Consider n number of the particles into m gives total mass of the body, that is capital M, into R1 square plus R2 square plus and so on plus Rn square whole by n. That is it. Therefore, I is equal to capital M into K square. Consider this is equation number 1. Since K square is equal to R1 square plus R2 square plus and so on plus Rn square whole by n. Since small m into small n is equal to capital M, that is equal to total mass of the body. And K is equal to radius of gyration gyration about the axis AB, where and K square is equal to R1 square plus R2 square plus and so on plus Rn square whole by n. Therefore, K is equal to root of R1 square plus R2 square plus and so on plus Rn square whole by n. This is called root mean square distance. This is equal to root mean square distance. Therefore, radius of gyration of a body about an axis defined as the root mean square distance particles from the axis. Once again I am repeating this statement. Radius of gyration of a body about an axis defined as the root mean square distance particles from the axis. Now the radius of gyration depends upon point 1 position and direction of the axis of rotation. Point number 2, distribution of mass about the axis of rotation. My dear students, this is about radius of gyration. I hope you understood this video. Thank you very much for watching this video.